Okay, guys, so one of the first things you're going to do for this lesson is you're going to work through the investigation of polygons, okay? So you should try this out. So this isn't actually part of the lesson, so try this out, pause the video, and then move on to the lesson part, okay? So a convex polygon is all line segments joining two vertices of a polygon lie on the inside of a polygon, okay? And then a concave polygon, some line segments joining vertices of polygon lie on the outside of the polygon. For this unit, for this lesson, we're only going to be looking at convex polygons. Okay, so you don't really have to worry too much about concave. It's just good to know the difference there on them. Okay. So we have two key concepts here. Okay. The sum of exterior angles of a convex polygon is always 360 degrees. So it doesn't matter how many sides, it's 360 degrees, okay? And then also for a polygon with n represents the number of sides, okay? The sum of the interior angles in degrees is given by the formula of sum of the interior angles, 180 times that number minus 2. Okay, so we can find the sum of the interior angles of any polygon as long as it is concave is the idea here. So for example, if we're looking at the following polygon, 1, 2, 3, 4 sides, okay, we can use our sum of interior angles. So I'm just going to use it as SOIA as short form, okay, and that's all right if you do too. So sum of interior angles equals 180 n minus 2. And again, we're replacing that value of n, okay, with 4 sides. Okay. So if we go 4 minus 2, we end up getting 2. Okay, so we actually find out that the sum of the interior angles of this particular shape adds up to 360 degrees. And then typically what will happen is we'll use that value to either solve other components for the day. Okay, so if we continue on, we'll just do a couple more examples here. I'll just change my color. So again, 1, 2, 3, 4, 5, 6 sides, sum of the interior angles, okay? Let's go to 180. And now if you feel comfortable enough, you could just, instead of writing the whole formula out, you can sub 6 right in to the formula. Okay. So 180 times 4, okay, is 720 degrees. So also a reminder, please don't forget units, okay? Units, okay? I know I stress this a lot, and I stress it a lot because students always forget. That's why. And then our last shape. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So sum of interior angles equal to 180. Okay. 8 minus 2. Okay. 180 times 6 gives us 1,080 degrees. Okay. So I'm pretty good too. I'm very fair that if I give you a shape on any type of assessment, I would actually tell you what that shape is. So for example, the question says, calculate the interior angles. And so make sure you read these questions, because interior, exterior angles, make sure you really read what they're asking for. Interior angles of a decagon. Again, I don't expect you to memorize all those shapes. So a decagon is 10 sides, okay? So again, it's just using our sums of interior angles formula to solve for that. It's just more put into a word problem sense. That's all it is, okay? So again, 10 sides minus 2. And we find out it's 1,440 degrees, okay? So that is the sum of the interior angles. So that's also key, because maybe the question might even be like, well, what's the vertices? What's the angles of those? So we'd have to do a little bit extra math here, okay? So we can also kind of look at this question in reverse. We can solve for how many sides a polygon has if we are given the sum of the interior angle. So in this situation, we're given the sum of the interior angle. So we're given the SOI, A. So with it 1,980 degrees equals 180 n minus 2, okay? And they're just asking you how many sides in this situation, okay? So it's just order of operations solving equations, okay? So we're just gonna isolate for n. So we'll divide both sides by 180 degrees. That would cross out, okay? So you'd be left with 11 equals, and now the brackets drop down, so n minus 2. So don't forget the minus 2 here, because sometimes people make errors here and they forget that. You have to move that negative 2 to the other side. So it becomes 11 plus 2 equals n. Okay. So then what we have found is 13 equals n. So therefore, we're looking at a 13-sided polygon. So I just want to do a side note, because this is going to lead me into my next question, kind of development of a formula. New formula, okay? So one of the things you could do in this situation is that if you knew what the sum of the interior angles was, and then you knew how many sides there was, you could find out how many degrees each angle is in that. And because we know it's a polygon and it's equal, okay, we're saying all sides are equal. So if we did 1980 divided by 13, we could find out that, you know, each of the vertices is equal to 152 degrees, okay? So that's just an extension, which is going to kind of lead me into a development of another formula for the next question. So how many sides does a polygon have if the interior angles of each measure 120 degrees? Okay, so they're saying the interior angles of each measure 120 degrees. Okay, so what we're saying is if we have a polygon, I'm just gonna like draw an open end, you know, each of these is 120 degrees, okay? So to kind of look at it, like it would be like saying, you know, the sum of the interior angles is divided by how many degrees to find how many sides kind of are. But we still have to deal with the 180 and n minus 2. But if we look at our previous example, n was on the bottom here. So we would multiply out n to the other side as well. Okay, so what we have is we kind of have a formula looking like this. Okay, so we're left with 120 degrees equals 180 n minus 2. And so we can kind of work from there as we get going. So when we multiply that n, it also applies to multiplying on the left-hand side of the equation. So we get 120 n equals 180 n minus 2. Okay, I'm just going to continue this over here. Okay. So you'll kind of recognize now distributive property is needed on the right-hand side of the equation. So we get 180 n minus 360. Now we can just collect like terms, okay? So you can go 120 n subtract 180 n equals negative 360, okay? And I'm going to divide both sides by a negative value of 1 to get rid of that negative here. Okay. So we end up getting 60n equals 360. And we can divide both sides by that 60 value to isolate for n. And we find out that the number of sides in this situation is 6. Okay. So again, that's 6 sides. Okay. So it's just really about reading the problem, because even sometimes like the next problem is an example of just like how simple a question can be. Okay. So if each exterior angle of a regular polygon is 30 degrees, well, we know all polygons exteriors equal 360 degrees, okay? So how many sides does it have? Well, this is very, very basic because we don't have to incorporate our other formula. We literally just have to divide it by 30 degrees, okay? Because we know that each of the exterior angles on this is 30 degrees, okay? So 360 divided by 30, it's letting us know that there is 12 sides, okay? So you didn't have to use the other problem because, again, it's asking exterior angle. Okay, guys, that is it for me. So you do have some homework with this lesson, okay? And that is out of the regular textbook there.